Today we are going to study the law of gearing. So first step is to draw the diagram, and it is very important to understand the diagram. So first of all we'll consider two arbitrary profiles which will transmit the motion. Let us consider the profile 1 is rotating about center A, and the second profile is rotating about center B. So A profile is rotating in clockwise sense with angular velocity omega 1 and transmitting its motion to profile B. So the profile B will rotate in counterclockwise direction with angular velocity omega 2. Let these two profiles are having a common point of contact. Let that point of contact, if it is considered on the first profile indicated by C, and if it is considered on second profile, let it be point D. So C and D are same points, but if it is considered on one profile 1, it is called as C, and if it is considered on second profile, it is point D. Now next step is to join A and C and B and D. Now if I want to find out the velocity of point C, then it can be found out by using a relation V is equals to R into omega. So for point C, the velocity Vc will be the distance between A and C point, that is R, is nothing but distance AC into its angular velocity, it is omega 1. So this is the magnitude, but what about its direction? So direction will be perpendicular to capital AC in the direction of rotation. So draw a line perpendicular to AC in the direction of rotation, indicating the velocity of point C. Now if I want to find out the velocity of point D, which is considered on second profile, then the magnitude can be found out by using same formula, V is equals to R omega, where R will be the distance BD and omega will be the angular velocity of BD, that is omega 2. So direction will be perpendicular to capital BD in the direction of rotation. So this is the velocity of point D represented by VD. Now next step is to draw the common tangent from the point of contact. So point of contact means from point C or D, draw a line which is tangent to both the profiles. So this TT line is the common tangent. Now draw a line perpendicular to TT from point C, means we are over here trying to draw the common normal. So common normal is represented by capital N. Now next step is to draw a line from point A which is perpendicular to common normal. So draw AE perpendicular to common normal from point A like this. Now draw a line BF perpendicular to common normal from point B. Draw a line which is perpendicular to the common normal, so that line is BF. So this is the basic construction that we will need while deriving the expression for law of gearing. Now the velocity will have two components. If we are going to consider the point C, its velocity Vc will have two components, along the common normal and along the common tangent. Similarly, Vd will have the component along common tangent and along common normal. For that, we'll need the inclinations of VC and VD along common normal. So let point A is making an angle alpha, or AC is making an angle alpha with AE, and the angle made by BF with BD is beta. So the angle in the triangle BFD, the angle made by FD with BD, this angle will be 90 minus beta. The remaining angle of VD with respect to the common normal will be obviously angle beta. So the total angle between BD and the velocity vector is 90 degree, and the angle between BD and common normal is 90 minus beta. So obviously the angle of this VD with common normal will be beta. Similarly, if you'll see in the diagram, angle CAE is alpha. So the remaining angle of this triangle at point C will be 90 minus alpha. The angle between VC and the common tangent will be same, that is 90 minus alpha. So the angle of inclination of VC with respect to the common normal will be alpha. Now, if there is to be continuous motion between the two profiles, then there should be relative motion along the common tangent. There should not be any motion along the common normal. If there is relative motion between the two profiles along common normal, then the two profiles either will get separated or one profile will try to penetrate into other. So why? There should not be any relative motion along common normal. So first of all, we'll try to see what are the components of velocity along common normal. So along common normal n, and the velocity Vc is having component Vc, the horizontal component. So it will be Vc, the angle made by Vc with respect to the common normal is alpha. So it will be Vc cos alpha. Similarly, the component of velocity component of velocity Vd along common normal and n will be Vd cos beta, as the Vd vector is making an angle beta with respect to horizontal. Now there should not be any relative motion along common normal means what? Vc cos alpha minus Vd cos beta must be equals to 0. So what is Vc? Vc is, we have already discussed, it is r omega, means what? A distance AC into its angular velocity. So AC into omega 1 into what is cos alpha from this diagram or from the triangle CAE. What is cos alpha? So cos alpha will be adjacent side upon hypotenuse. So adjacent side is AE upon hypotenuse is AC minus VD. VD is the product of R into omega, that is R is BD into omega 2. So BD into omega 2 is the value of VD into cos beta from triangle BFD. Cos beta is BF upon BD. BF upon BD must be equals to 0. So in this case, AC will get cancelled, BD will get cancelled. So what we have, omega 1 AE minus omega 2 BF is equals to 0. Omega 1 AE is equals to omega 2 BF, or we can write omega 1 upon omega 2 is equals to BF upon AE. Okay, but if you see, the A and B points are the centers of rotation, and I am going to join them by a straight line. So the line joining the center will cut the common normal at a point, let it be point P. So we'll get two triangles, BFP and APE. Now these two triangles, angle AEP is 90 degree and angle PFB is 90 degree. So these two angles are same. Similarly, angle APE is same as that of angle FPB, which are opposite angles. Hence, we can say that the triangle APE and triangle BFP are similar. These two triangles are similar. Hence, we can write omega 1 upon omega 2, which is BF upon AE, is also equals to. Now, BF is one of the side of triangle BFP. So instead of BF, I can write it as PF or BP. So I will rewrite this as BP upon the another side is AE in triangle APE. The side AE, instead of side AE, we can write it as PE or AP. So I will rewrite it as AP. So omega 1 upon omega 2 is equals to BF upon AE is equals to BP upon AP. So this is the required equation for law of gearing, relation for law of gearing. So we will see what we can conclude from this. Now we know that omega 1 upon omega 2 is equals to BP upon AP. So we can conclude that the line joining the centers, that is line AB, is divided by point P in the inverse ratio of the angular velocities of the two gears, as omega 1 is related to first gear tooth profile and BP is related to the second gear tooth profile. Omega 2 is related to second gear tooth profile, while AP distance is related to first gear tooth profile. If it is desired that the angular velocities of the two gears remain constant, the common normal at the point of contact should always pass through a fixed point P, which divides the line joining center, that is line AB, in the inverse ratio of angular velocities. So if this condition is satisfied, then that particular geometry can be used for manufacturing of gears.